4 forward. 4 forward. Drift into the right a little. 20. Down a half.
30 seconds.
Forward. Just. Good. Okay. Contact light. Okay, engine stop. APA at a descent. Mode control both auto. Descent engine command override off. Engine arm off. 413 is in.
We copy you down, Eagle.
Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
When Neil Armstrong and Buzz Aldrin became the first people to land on the moon in the summer of 1969, they were in constant contact with Mission Control back on Earth. Mission Control was located at the Manned Spacecraft Center in Houston, Texas, now known as Johnson Space Center. Much more than just Mission Control, MSC or JSC had been one of the key centers of NASA's human spaceflight program since 1962, and it remains so to this day for Gemini, Apollo, Skylab, Space Shuttle, International Space Station, and now the Artemis Moon program. Astronauts have lived in Houston and trained at the Johnson Space Center for their missions beyond the Earth's atmosphere. Astronauts are just one part of human spaceflight, and JSC is concerned with every aspect of human spacecraft development and operations, not just astronauts. In addition to astronaut training facilities and the Mission Control Center, JSC has a wide variety of engineering laboratories for testing nearly every part of a spacecraft and refining its design, long before it ever flies into space with astronauts on board. NASA really does some interesting work at JSC, and the public has been interested in seeing what's going on there ever since the center opened. In the early days, NASA hosted open houses and ran public tours on the grounds of the Space Center. Today, the visitor experience is provided by Space Center Houston, a deluxe visitor center operated by a private nonprofit organization called the Manned Spaceflight Education Foundation. In spring break 2003, I visited Johnson Space Center with my parents. I was 16 years old and in the 11th grade, and I'd wanted to visit JSC for about 7 years by that point. JSC played a central role in the Space Shuttle program, and I'd grown up in an America that was proud of its Space Shuttle and the technological sophistication that it represented. But when we visited in 2003, the Space Shuttle program was in flux. Just 7 weeks before our visit, Space Shuttle Columbia broke apart during re-entry of the Earth's atmosphere and crashed in eastern Texas, killing all the crew members on board. Although we couldn't know it at the time, this disaster would have far-reaching implications for the Space Shuttle program and NASA as a whole. It would lead to the cancellation of the shuttle program and a shift in NASA human spaceflight priorities from low Earth orbit operations to deep space exploration. I'm going to share some video and impressions from my visit to JSC when I was a teenager. But before that, we'll take a look at the history of JSC from the 1960s up to my visit in 2003. Everything has a history, and Johnson Space Center is no exception. By the time we visited, JSC had been in operation for 40 years, and it had directed NASA human spaceflight programs from Gemini to the Space Shuttle. This is the story of Johnson Space Center. On October 4, 1957, the Soviet Union launched the world's first artificial satellite, Sputnik 1. This was a remarkable technical achievement for a country that had only recently industrialized and had then been devastated during World War II.
But since this was the Cold War, the United States and the Western Bloc saw Sputnik not as something to be celebrated, but as a threat. In response to Sputnik, Congress passed the National Aeronautics and Space Act, which President Eisenhower signed into law on July 29, 1958. The bill created the National Aeronautics and Space Administration, an independent agency of the federal government that would direct civilian space activities. NASA absorbed the National Advisory Committee on Aeronautics, which had operated since 1915. More than just a committee, NACA was a full-fledged research organization with several research facilities around the country, including Langley Aeronautical Laboratory in Virginia, Lewis Flight Propulsion Laboratory in Ohio, Ames Aeronautical Laboratory near San Francisco, and the High Speed Flight Station in the Mojave Desert north of Los Angeles. The new space agency absorbed these research facilities and turned them into NASA centers. NASA grew quickly after its birth in 1958. The new agency had a broader mission than NACA, and it was more focused on operations and development than pure research. In addition to the original NACA centers, NASA acquired the Army Ballistic Missile Agency in Alabama, which became Marshall Spaceflight Center. Marshall would serve as the main engineering and industrial facility for the development of space launchers, like the Saturn V moon rocket. NASA also began construction of an all-new facility just outside of the District of Columbia, Goddard Space Flight Center. Later, it would build Kennedy Space Center, a vast new launch facility just north of the Air Force Missile Range at Cape Canaveral in Florida. Shortly after the founding of NASA, an organization called the Space Task Group began work on what would become Project Mercury, NASA's first human spaceflight program. The STG was initially housed at Langley, but it didn't truly belong there, as Langley was still mainly a research center in the NACA tradition, while the STG was focused on operations. The Space Task Group would ultimately grow into a full-fledged NASA center, the Manned Spacecraft Center. This center would take charge of the development and operation of NASA's crewed spacecraft. It would also be the home base for the astronauts and their trainers, and it would house mission control and some of the other ground facilities. T. Keith Glennon, the first administrator of NASA, was largely responsible for the decision to move the STG to a new site and make it a full-fledged center. After Glennon left NASA in January 1961, at the end of the Eisenhower administration, a committee set to work looking for a new home for the Manned Spacecraft Center. The committee was looking for a site that satisfied the following criteria: access to water transportation for large barges, a moderate climate, all-weather jet service to the area, developed industry, a culturally attractive community, a university, good electrical and water supply, and at least 1,000 acres of available land. The committee considered a total of 23 sites, which included 2 military bases in Florida, 3 cities in Louisiana, 3 sites around Houston, 5 other cities in Texas, 4 sites around St. Louis, Camp Elliott in San Diego, and 4 sites around San Francisco Bay. Between August 21 and September 7, 1961, the search committee visited all 23 sites, from Florida to California. Each visit included meetings with local dignitaries and townspeople, and visits to the proposed site and the nearby university. After these visits, the committee determined that MacDill Air Force Base in Tampa was the front runner. This place would soon have space available for NASA because the Strategic Air Command was planning to close down its operations there. The runner-up was a plot of land in Clear Lake, outside of Houston, that Rice University offered to donate to NASA. In third place was the Benicia Arsenal, northeast of San Francisco. Tampa could have become the home of the Manned Spacecraft Center, if things had turned out a little differently. But as things happened, the Air Force decided not to close down MacDill Air Force Base after all, thus removing it from the running. Houston moved to first place and won the competition. President Kennedy was informed of the decision on September 14, and the public learned about the decision 5 days later. MacDill is still an operating Air Force base in Tampa. The Benicia Arsenal, which became the runner-up after MacDill was removed from the list, was closed down in 1964. Most of the area has been redeveloped for industry, but some of the original Arsenal buildings now house the Benicia Historical Museum. I wonder how this place would be different if it had become a NASA center instead. Houston was an ideal site for the Manned Spacecraft Center in many respects. It satisfied all the requirements that NASA was looking for in a site, including barge access to the ocean by way of Clear Lake and Galveston Bay. In addition, Houston also offered a chance for political patronage. Texas was a powerful state in national politics in the early 60s. The vice president and head of the Space Council, Lyndon B. Johnson, was a Texan. So was Sam Rayburn, the Speaker of the House. Houston was in the district of Congressman Albert Thomas, chair of the House Appropriations Committee. Other well-connected Texans in government were Bob Casey, a member of the House Committee on Science and Astronautics, and Olin Teague, chair of the Subcommittee on Manned Spaceflight. The Space Task Group officially moved to Houston and became the Manned Spacecraft Center in 1962. At this point, though, MSC consisted only of an undeveloped site in Clear Lake and rented offices in downtown Houston. The Mercury Project Office stayed behind in Virginia. As MSC employees and their families relocated to Houston, the U.S. Army Corps of Engineers designed the new Manned Spacecraft Center and selected contractors to build it. By 1964, the new center was up and running and gearing up for the Gemini program. Project Gemini was NASA's second human spaceflight program, and it was much more complicated than Mercury had been. Mercury consisted of small capsules with one-man crews, which could not change their orbit once launched. The longest Mercury mission lasted all of a day and a half. Gemini had two-man crews, with vastly more complex missions, featuring rendezvous and docking, spacewalks, and long-duration flights of up to 2 weeks. Gemini filled a gap between Mercury and Apollo, and it gave NASA crucial experience for the subsequent moon program. Project Apollo was more complicated still. It required three-man crews to make missions to the moon. 2 astronauts would descend in the lunar module to the moon's surface, while a third would stay behind in the command module and look after the ship. Apollo entailed lunar stays of up to 3 days in length, with extensive surface exploration and geological studies. Starting with Gemini, astronauts moved to Houston and used the Manned Spacecraft Center as their home base. The astronaut office was located in Houston, as were the trainers and simulators that the astronauts used to prepare for flight. When they needed to visit other NASA centers and the facilities of contractors, the astronauts would fly T-38 jet trainer aircraft out of Ellington Field, adjacent to the Space Center. Shortly before launch, the astronaut crews would relocate to temporary quarters at Kennedy Space Center, where they would continue their training on a second set of trainers up to the last days before liftoff. Sad to say, the early days of the space program placed a heavy toll on the astronauts and their families. The astronauts worked very long hours, and they were often gone from Houston. The divorce rate for Gemini and Apollo astronauts was high. In addition, flying the early T-38s could be dangerous, and several astronauts were killed in jet crashes before they ever made a flight into space. The astronaut office was merely the most visible part of the Manned Spacecraft Center's activities. Once fully built in 1964, MSC was a vast facility employing 2,700 people who worked on all aspects of engineering and operations of human spaceflight. While Marshall Space Flight Center was responsible for development of the rocket boosters, and Kennedy Space Center integrated the flight hardware and launched it, MSC oversaw the design, construction, and operation of the spacecraft that the astronauts rode into space, from initial concepts through flight and all the way to splashdown in the ocean. The Manned Spacecraft Center had a wide range of sophisticated industrial and laboratory facilities, which were used in the development and testing of spacecraft systems and complete vehicles. Probably the most impressive of these facilities was the Space Environment Simulation Laboratory. As the name suggests, the SESL was able to replicate some of the conditions of space on Earth, including near vacuum, extreme cold, and intense sunlight. The SESL consisted of two large domed chambers. Chamber A was 65 feet in diameter and 120 feet tall, while Chamber B was 45 by 43 feet. The facility came online in 1966, and it was first used for testing Gemini pressure suits and Apollo Block 1 capsules in a space-like environment. The tests on the Apollo capsules revealed some flaws in the design that were fixed before any of the spacecraft flew. The nerve center of American human spaceflight was Mission Control, located in Building 30 in the heart of the Manned Spacecraft Center. The Mission Control Center came online in 1965, and its job was to direct a spacecraft's flight from launch all the way to landing. The MCC included two Mission Operations Control Rooms, which were outfitted with IBM computer terminals that allowed mission controllers to monitor all aspects of a spacecraft's performance. The first crewed flight that was directed from this facility in Houston was the Gemini 4 mission in June 1965. In 1973, the Manned Spacecraft Center was officially renamed the Lyndon B. Johnson Space Center. The new name honored the Texan senator and president who had been a key proponent of the space program since the creation of NASA. It also reflected the fact that the astronaut corps would soon cease to be exclusively male. American women would start flying into space in the 1980s. At the time of the name change, the Space Center was involved in Apollo applications, which used leftover Apollo hardware for Earth orbital missions. The last Saturn V rocket launched Skylab, America's first space station, into orbit in May 1973. 3 crews visited the station in succession later that year. The last Apollo application mission was a rendezvous and docking with a Soviet Soyuz spacecraft in 1975. This mission was part of the détente period of the Cold War, an easing of tensions with the Soviet Union before tensions rose again in the 1980s. Apollo-Soyuz was the culmination of several years of diplomatic negotiations and technology transfer in order to integrate 2 very different spacecraft that had been designed and built completely separately from each other on opposite sides of the world. Throughout the 1970s, the Space Center also developed the Space Shuttle, NASA's workhorse space launcher for the 1980s and beyond. proposals for a reusable next-generation space shuttle dated back to the mid-60s. NASA tried hard to get a fully reusable shuttle concept to work, but it would have been very large and very expensive to develop. Instead, NASA settled on a partially reusable design, consisting of a reusable orbiter, reusable booster rockets, and an expendable propellant tank that would serve as the backbone for the entire structure. President Nixon approved the space shuttle in January 1972, and NASA and civilian aerospace contractors got to work on it. Developing the space shuttle was a major undertaking, and it required technology that was beyond the current state of the art, including a reusable thermal protection system and throttleable, reusable cryogenic space shuttle main engines. Johnson was the lead NASA center for the space shuttle project, and it also took responsibility for the development of the orbiter. Marshall was responsible for the solid rocket boosters, the external tank, and the space shuttle main engines, which were mounted on JSC's orbiter. Kennedy integrated the flight hardware and launched it, using repurposed ground support equipment from the Apollo Saturn program. Johnson Space Center also reused plenty of Apollo-era hardware for the Space Shuttle program, such as the Space Environment Simulation Laboratory. But the shuttle required some new facilities and equipment as well. By far the most expensive laboratory facility built during the development of the shuttle was the Shuttle Avionics Integration Laboratory, which developed the electronics used on the shuttle. These electronics were another technology that was beyond the state of the art at the time. The Avionics Integration Laboratory supported each flight of the shuttle program by simulating the avionics configuration for each mission. For mission training, astronauts used the SMS, the Shuttle Mission Simulator. In addition, a building that had formerly housed a centrifuge for astronaut training was converted into the WET-F, the Weightless Environment Training Facility, a large swimming pool that astronauts could use for practicing extravehicular maneuvers in neutral buoyancy. The first new astronauts for the shuttle program were selected in 1978 and moved to Houston to begin their training. These astronauts were more diverse than the Mercury, Gemini, and Apollo astronauts had been, and hence they were more representative of the American population. They included Sally Ride, the first American woman in space, Guy Bluford, the first African American to fly in space, and Ellison Onizuka, the first Asian American astronaut. The first space shuttle flew with great fanfare in 1981, and it looked as if a new age of routine, inexpensive access to space was dawning. But the shuttle never lived up to its expectations. It turned out to be harder to maintain and far more expensive to operate than anyone had anticipated. It also had a poor safety record. In 1986, on the 25th shuttle flight, Challenger broke up at liftoff, killing all 7 of its crew on board. In the post-Challenger shakeup, NASA decided to limit the use of the shuttle to missions that required a human's presence in space. JSC lost its status as lead center of the shuttle program, but it continued to play a central role in shuttle operations. In the 90s, the shuttle launched and serviced the Hubble Space Telescope, performed scientific missions, and launched some deep space probes. It also began assembly of the International Space Station, a scientific outpost in low Earth orbit. With its large cargo bay and remote manipulator arm, the shuttle was ideally suited for the job of assembling the space station. But then another tragedy struck the shuttle program. Space Shuttle Columbia broke apart on re-entry at the end of a scientific mission in February 2003. The remaining shuttles were grounded again, and NASA set about investigating the cause of the disaster and setting its course for the future.
That brings us up to my visit to JSC in 2003. My parents and I were staying with one of my mom's cousins in Houston, and the three of us drove out to Clear Lake on a Sunday morning to make the most of our time at the Space Center. To be precise, we spent most of our time that day not at JSC proper, but at Space Center Houston. As I mentioned in the introduction, Space Center Houston is a glorified visitor center run by a private nonprofit called the Manned Spaceflight Education Foundation. Kennedy and Marshall Space Centers also have expansive visitor facilities that are not run by NASA. These facilities are showier than they strictly need to be, and they can get expensive. When I was younger, I used to wish that NASA would run these visitor centers itself. Now I get why NASA doesn't, because providing visitor experiences is not NASA's job. NASA is not the National Park Service. I do wish that the visitor centers were less commercialized and less theme parkized, but it is what it is.
One of the first things we did when we arrived was go on a tram tour of NASA facilities on the grounds of the Space Center proper. I had been most eager to see the Mission Control Center, but we didn't get to see it. Either the older Mission Operations Control Room from Gemini and Apollo, or the newer Flight Control Room used for the Space Shuttle. I'm guessing that the Mission Control Center was closed because of the loss of the Columbia, just 7 weeks earlier, but I haven't been able to confirm that. We did get to see a variety of simulators and training mock-ups of the Space Shuttle and other spacecraft. One of the buildings we visited was the Space Vehicle Mock-up Facility, or SVMF. This was a large building with training mock-ups laid out on the floor of a long, multi-story room. The trainers included various versions of the Space Shuttle, dummy modules of the International Space Station, and even a Russian Soyuz. Most of these trainers have been transferred to museums around the country since the retirement of the Space Shuttle. In another area, we got to see the Shuttle Mission Simulator, which was still in use more than 20 years after it first came online. The SMS consisted of several different pieces of equipment. The fixed base crew station modeled the entire cockpit of the shuttle. The motion base crew station only had the commander's and pilot's seats. It was mounted on hydraulics and had 6 degrees of freedom of motion. Both crew stations had computer systems that simulated every detail of the shuttle controls and instrument readings. They also had television monitors in the windows that displayed computer-generated images of the view outside. In 2003, I thought the simulators looked pretty quaint, but they were very sophisticated machines when they were built in the 70s. I'm sure I'd appreciate them better now. The last stop on the tram tour was the Rocket Garden. There was a grand total of only 3 rockets on display: a Mercury Redstone, a Little Joe 2, and a Saturn V. It was fun to see the Redstone and Little Joe. Just a couple of weeks earlier, I'd launched model rockets of both of them.
4, 3, 2, 1.
Whoa! Mercury Redstone was adapted from the Army's Redstone missile. It launched the first 2 Americans into space in 1961. It also launched 2 earlier test capsules, one of which was crewed by a chimpanzee named Ham. Little Joe 2 was built to test the launch escape system of the Apollo spacecraft, which was designed to pull the command module away from the rocket in the event of an emergency just before launch or early in flight. 5 of these rockets made test flights at White Sands Missile Range in New Mexico between 1963 and 1966. While this rocket on display, of course, never flew, the capsule on top did. It is boilerplate number 22, and it was launched on a Little Joe 2 in 1965. The Mercury Redstone and Little Joe 2 were neat to see, but I was most interested in the Saturn V. This rocket was designed and built especially for launching 3 people to the moon and bringing them back to Earth. In 2003, the rocket was on display outside, lying on its side, separated into its individual stages. There are 3 Saturn Vs on display like this, but the Saturn V at JSC is the only one that consists entirely of hardware that was actually built to fly. The Saturn V's at Kennedy and Marshall include stages that were built for ground tests rather than flight. Unlike the Space Shuttle, the Saturn V was built to be within the current state of the art, not to develop far-fetched new technologies. Even so, designing and building the Saturn V was a tremendous engineering accomplishment, and the surviving Saturn V's are impressive sights. The tram tour dropped us off at the bottom end of the rocket, with 5 giant F-1 engines mounted on the bottom of the S-1C stage. The S-1C burned liquid oxygen and RP-1, rocket-grade kerosene. This stage was built by Boeing at Michaud Assembly Facility in New Orleans, then transported by barge to Kennedy Space Center or to Houston. The second stage is the S-2, which was built by North American Aviation at Seal Beach, California, then transported through the Panama Canal to Kennedy. It also had 5 engines, but these were J-2s, which burned liquid oxygen and liquid hydrogen. Cryogenic liquid hydrogen is a lot fussier than RP-1, and North American had some trouble developing this stage. The last stage is the S-4B, with a single J-2 engine. For a lunar mission, this was the most important stage of all, because it had to burn for a brief period to place the Apollo spacecraft stack in an Earth parking orbit, and then it had to restart in space for the trans-lunar injection burn. This stage was also built in California by Douglas Aircraft Corporation in Huntington Beach. S-4B stages were test-fired outside of Sacramento before delivery to NASA, although this one never was, apparently because of budget cuts. These stages were transported by a custom cargo transport plane called the Super Guppy, which also transported the Apollo spacecraft. NASA still uses a Super Guppy for transporting large spacecraft modules. At the top of the stack were the spacecraft themselves. The lunar module was housed inside this cone-shaped fairing, but it is missing from this display. There is a command service module on display, and it is the real deal, not a boilerplate or mock-up. It was built for a mission that was canceled. At the very top of the stack is the launch escape system, which is what Little Joe 2 tested. Having been outdoors for decades in humid and stormy East Texas, the Saturn V was rather the worst for wear by 2003. Not long after our visit, the rocket was restored and placed inside a protective enclosure. But I'm glad that I got to see it before it was enclosed, because I could get a more complete view of it and better appreciate its size. After visiting the rocket garden, we returned to the main visitor center. We walked through a museum called the Starship Gallery, which had space program relics from the early days to the Space Shuttle era. We got to see some early spacecraft: the Faith 7 Mercury capsule, flown by Gordon Cooper in 1963, the Gemini 5 capsule, and the Apollo 17 command module America. There were also several lunar samples on display, which included 4 moon rocks larger than a grapefruit. We could touch one of the smaller samples. One of the most interesting artifacts to me in the Starship Gallery was a full-scale Skylab training mock-up. The hull of the space station was actually a converted S-4B, the Saturn V third stage. This meant that it was big. Since the training mock-up was lying on its side, we could walk through it and look at the various rooms and pieces of equipment inside, as well as a spinning astronaut dummy. By about 6 o'clock, we had seen everything there was to see. After hitting the gift shop and buying a lot of stuff, we left satisfied. We had enjoyed a good 8 hours of sightseeing. I had gotten a better appreciation for the kind of work that NASA does, and I'd enjoyed the chance to see some hardware and facilities from the present and past of space travel.
Thanks for watching my video. I hope you enjoyed watching it and maybe even learned something in the process. I can tell you that I learned a lot while researching and writing the script for this video. My main source for the history section of the video was a book called Suddenly Tomorrow Came by Henry C. Detloff. This book is part of the NASA History series. There have been quite a few of these books written over the past 50 years, and let me tell you that I love them. NASA history books are academic and well-researched, but they're also well-written. The authors also have academic freedom as they write. If you want the official word on anything from NASA's past, seek out the NASA history book on that topic, and you won't go wrong. I've put a couple of recommendations for other NASA history books down below. I'd like to thank Johnson Space Center and the NASA History Office for the work that they do. I'd also like to thank Space Center Houston for taking our admission money 20 years ago and giving us access to JSC. Special thanks to my parents for taking me to Houston for that spring break and for appearing in this video. And I'd like to thank you once again for watching. This is Willie Logan in California, over and out.